Okay. Ready? 9.4. I like to specify 9.4 for one reason, because I'm using the alter system. So if you want the alter system, in my example, I'm using the alter system. So if you want the alter system, use the 9.4. Otherwise, it will fail miserably. Streaming replication. To be honest with you, I'm not going to immediately drop for the stream of the streaming replication, because we need some background. Not everybody knows how Postgres works. Not everybody knows, but they're not into the database thing. So I want to explain how the Postgres work, how the async work, and how Postgres prevents us to lose our database. So I divided in 4 sections this presentation: crash recovery and their band of merrymen. So I will explain the crash recovery procedure. Point in time and recovery in space. I am a huge fan of Doctor Who, just guess. If of broken walls, how the how the standby servers can be configured from the point in time. And finally, now something completely different: the streaming replication, completing our picture and making our system incredibly efficient for the HA. So let's go. You know this picture? Right. Yeah. This was on my statistic books, the introduction to the analysis of the error. I love it because it explains how the a small mistake can lead to massive disaster. Just little workaround. Postgres is a ACID compliant database. ACID is an acronym for which expresses the atomicity when the transactions are all or nothing, when the consistency, when the database is moves from one valid state to another valid state with no exceptions. Isolation, when the transaction can be executed in serial and then reconstruct the database state from this serialization. And finally, the one we'll explore tonight, durability of is a property that ensures the transaction, when it's being committed, is saved on durable storage. And even if the database crashes, it's possible to recover from this crash. So, yes, Postgres implements this thing using the write-it log. The write-it log is a very interesting thing. Is the way of writing the things after the changes are happened into the volatile memory, into a durable storage called WAL, W-A-L. I made a little scheme about this thing. This is very basic. I'm not comprising everything. For example, it's missing the checkpointer, but it gives an idea. We have the data area, which is durable storage, our bank for our data, for our physical blocks. The shared buffer is volatile memory. If you pull the cord, it's lost. It's completely discarded. The backends connecting to the shared buffer and accessing the blocks loaded into the shared buffer. A small amount of memory called the WAL buffer, where the logs are stored, and the WAL writer saving our important information on the durable storage, the WAL. Also is the PGX logging to the directory structure. So what happens? The backend in Postgres, everything passes through the shared buffer. There's a reachable set of routines to get the blocks constantly pinged by just one backend to be sure the data is modified only by one backend and there's no inconsistency across the changes. So the backend requires the block read from the data area, loads into the shared buffer, and that's happened. The backend pings the block. It means no other backend can access this block. Change the data, and that happened the magic, because as soon as the transaction is committed, as soon as the transaction is committed, a xlog record is stored inside the wall buffer, and after a certain timeout, the wall writer writes down on the wall this change. The timeout is usually, I want to be wrong, it should be around 200 milliseconds by default. It can be adjusted depending on your throughput. And what's inside is xlog record, called xlog record. There's the information about the block changes, and the new tuple structure, the new tuple value. So if you have a small tuple, you generate a small record. If you have a long tuple, you generate a lot of data stored inside the wall. So yes, the wall segments are stored inside the directory pgdata pgxlog. Each segment is usually 16 megabytes. You can change this size, but you need to recompile the database, re-init DB, reload the database. And so it's very uncommon to find different sizes. Same story for the database page size. It's 8K, and I never seen in my life different sizes. So the WAL file is 16 megabyte segment. Is written from the bottom to the top. When it's full, the database jumps to another segment. This segment can be created as new, or can be recycled from the other segments. All the management is made automatically by Postgres, and is influenced by the checkpoint event. I will talk later about the checkpoint, yes. So what happens to the page when it's in memory and is changed? It becomes dirty. It means the data is changed into the memory. So if another backend asks for the page, it will see the change. But it's no longer consolidated on disk. So if we lose the database at this point, the change is lost, but not really, because the change is already logged into the WAL file. The write, the real write, happens when the background writer, a process I didn't count inside the previous schema. The background writer is a very small process. From time to time, he wakes up, scans the shared buffer, gets all the dirty pages, and writes down the corresponding data files. This is very useful. It was introduced a long time ago, because when the checkpoint started with the old glorious 7.4, there was a massive I/O spike, because all the dirty pages are written by the checkpoint. All the dirty pages visible inside the checkpoint snapshot. Now we are in the modern times, so we have the background writer, and also we have the so-called spread checkpoint. Checkpoint aims to complete in a certain amount of time, usually by default is 1.5 minutes. In 1.5 minutes, checkpoint shall complete. So it never gets hurry, because if we lose the shared buffer, yes, that's it. If we lose the shared buffer, we still have the WAL. So checkpoint. Now from the 9.3, there is a dedicated process called checkpointer. All the dirty pages are written to this. The control file, I didn't mention, but is a 8K file inside the Postgres data area, where there's stored vital information about the database. And in particular is the last recovery location, the name of the WAL file from where the database shall start the recovery. If for some causes it shuts down, not cleaning. Oh, that's another interesting thing. the WAL files are recycled or removed. So never rely on the WAL files inside the PGX log because they can disappear or change name. So what happens if the server crashes? At the startup, the control file is accessed. The database detects the database was still in production state. So there's no end of instance clear stored inside the control file. So the WAL file, the control file tells the database startup process, which is the last recovery location to start with the recovery. The WAL files are scanned, reading from the Xlog, the blocks are loaded in memory, replay the changes, and not written. Because when all the WAL files are replayed, at the end of the recovery, there's a checkpoint. So there's no hurry to write down the changes, because at the end of the, before the database becomes available, there's another checkpoint which consolidates the data recovered already onto the data files. There's another interesting thing. When this happens, the parameter, don't know if anybody knows, zero page. It's called zero page. It's an obscure parameter. It means if you get corruption on your data page, zero, and then rewrite down the entire change. So if there's any corruption on the data page, the database continues to recover it, because in any case it will reconstruct the data from the WAL file. Of course, this needs to be set the recovery full page writes on, so recovers for the entire full page writes. So we have our single instance. We can crash the instance. We can still recover the data. Let's see how can we take advantage of this thing. Hello, that's me. That's my girlfriend. Me as the fourth doctor, and my girlfriend as the Peter Davison, the fifth doctor. So when the server switches to another WAL file, the WAL file becomes unused. And when the checkpoint happens, this WAL file can be recycled. So when the next checkpoint happens, of course. If we save this file into another location, we archive. This is a well-known concept into the Oracle universe, and from the 8.0, it was in 8.2, it was introduced in Postgres. We can still save. We can save this import information in another location. So if we take, meanwhile the database is running, we take a copy of the database itself with rsync or anything, we can reconstruct using the WAL files, and the database crashed our database as it was before, right? Very simple. Really? Not exactly. There's just a little, some close to set up. We have a problem, and for this fantastic work, I cannot say thank you to Simon Riggs. He made all the entire thing to become true. He made a fantastic job. The control file is constantly written, so we cannot rely on this when we copy the running data area, because the database will search, the recovery instance will search for two recent WAL file for starting the recovery. So we need to save our information in some other place. There's also another problem. The WAL file, by default, the so-called minimal configuration, it doesn't contain the transaction commit statuses. I didn't talk about the fantastic directory called pg_clog, where all transaction statuses are logged. But unfortunately, this thing, usually by default, is not logged into the WAL file. So we need to transfer this information to the slave. And also, there's no the vacuum record inside the WAL file. So we need some adjustments, and Postgres have some parameters to set up. First one, tell the database you want to archive your WAL files. So set to on the archive mode. Number two, WAL level set to archive, off standby, or logical. Logical is a newer version when you can store the logical changes alongside with the Xlog. I'm not reading about this. This is pretty complicated. Maybe next time we can do it. Some interesting talk. And what's the difference between archive and off standby? The archive is for feeding a so-called warm standby, so just in recovery, not accessible. The hot standby adds a slight overhead on the archive mode, but permits to have the standby accessible in read-only mode. So we will see this thing. There's another simple command. Oh, sorry, I forgot one thing. Changing those parameters needs server restart. So plan before doing anything. And there's another interesting catch. If you set the archive mode and you don't change the WAL level, the database doesn't start. So be very, very careful of what you are doing. Archive command is the command to tell the database where to archive the WAL files. If somebody comes from Oracle, there's a horrible configuration stored inside the control file, the archive multiplexing. So set the archive location is stored into the $v$ config, all these sort of things. Nothing so sophisticated. It's just CP or rsync or whatever you want. Even a shell script, it can be stored inside the archive command, something like this. This is the adapted from the manual, the online manual. It's very, very simple. Test if the file, %f means the WAL file name is a variable substitution. So check if the WAL file is already exists. If it doesn't exist, copy the WAL file from the pgxlog %p, which is the pgxlog with the entire path, into my directory with this file. So every time we have a log switch, this command is called. If this command fails for some reasons, it stores the WAL file is kept for the archival, which is incredibly dangerous because if the pgxlog runs out of space, the database crashes. So setting up this sort of things is very critical, requires attention, because it can lead to a database crash if, for some reasons, this command fails. At this point, we have changed the settings, we changed the archive location. Now we need to tell the database that we want the backup. So we have this very handy function called pg_start_backup. Just guess what it does. This function accepts two parameters. One is the label. Another one is the checkpoint mode. You remember before I mentioned the spread checkpoints. But this command can work in two ways. Doing a spread checkpoint, if we set to false this parameter, or do an immediate checkpoint. So checkpoint all the pages as fast as possible because we want to start our backup as fast as possible. So usually the usage is to set this thing, but maybe for highly loaded servers, it's better to spread checkpoint. Anyway, issue this checkpoint. As soon as the checkpoint is finished, the recovery location determined from the checkpoint is written into a backup label where all this information are written. Start location, the WAL file from where to start the recovery, checkpoint location, backup method, the function name, from the master, the start time I did on my PC some days ago, and the label it's quite important to set the label if you have multiple servers feeding from the same server. Maybe you. It's also important to store maybe the kind of backup, the reason for the backup. So it's useful to have it. At this point, when the backup starts, nothing changes from the database point of view because it's just the backup label inside. The difference with Oracle, when the table space becomes start backup, Oracle starts writing massively the changes onto the redo log. This does little difference. There's just a backup label saved for our usage into the server. So save the running cluster, rsync, copy it, rcpio, choose one, and archive your data. So on one side you have your WAL files archived, and on the other side you have your precious data area, not consistent, but with the WAL files you can still recover the entire thing. And when everything is finished, when the rsync of the copy is finished, tell the database as soon as possible that the backup is finished. The database removes the backup label and does a switch log file. So the last log, meanwhile the stop backup was running, is still archived, and the last precious information is archived. Because from the moment when you start the backup to the moment when you stop the backup, the slave or the point-in-time recovery is in inconsistent state. As soon as the recovery location stored there, displayed there, is reached into the recovery process, the database becomes consistent, so you can open for connections. So procedure, very simple. If we need to recover from this thing, restore the data directory. Inside the data area, create a text called recovery.conf and set up the parameters for recovering from our archive. So tar xfs, the archive, so you get the data area, and inside is sufficient this. Restore command, cppg archive, %f%t. It's exactly the opposite of the archive command. You tell the startup process to get the data from the archive and copy it into the PGX log. This is a very important concept. The recovery never happens from the archive. The WAL file has to be copied into the PGX log, where is the natural place for the database to start the recovery. And this is one of the problems of the archive mode. Few new parameters. Recovery target immediate. When this is set, as soon as the database reaches the consistent state, becomes read write. Because at this level, we are still getting a running database completely different compared to the original one. Why it's called point-in-time recovery? Because we can stop the recovery at a certain point in time after the database has become consistent. So we can stop before maybe a dangerous drop and restore the data 1 second before this data has been lost into the master. This is more powerful than the logical backup, because the logical backup saves a snapshot. In this case, we have a very live working system. Recovery target time, you say the timestamp when you want to stop, and the database stop 1 second before the drop. Obviously, you need to catch the moment when the drop happened. This is quite interesting. You can include or not include the stop of the recovery target. And yes, so what it does, the point-in-time recovery? It gives us the protection from the disaster recovery, but not yet for the high availability. Which, as I said before, it comes very handy if somebody drops the table by accident. alongside with this. This is very useful for punishing the oh, the author states that this belongs to his girlfriend. I can't imagine what happened on this. So now we move forward to the if broken world. So move from the point-in-time recovery to the standby servers. Gosh. Gosh, playground. I did a long time ago this picture. So yes, I said before, when the recovery target is reached, the instance opens and generates a new timeline. Yes, in Postgres they are implemented the timelines. Is quite crazy. Please, if you are curious, read the documentation. It has an extensive explanation about this, but it's similar to time travel and parallel universes. So it's very, very interesting. So the new instance follow a different universe compared to the initial copy. But we can also say to the recovery.conf to say, okay, do not open, do not complete your recovery. Wait for the next WAL files, whether it's received or not. In this way, we set up a standby server where the server waits for the changes from the master, in our case, archived through the WAL files. And in this case, we have the high availability because our server is available seconds before the master to become a new master if the original one dies. So we can fail over as fast as possible. We can also have the warm standby implemented in the old glorious 8, where there was no access to the server, and the hot standby, which opens our servers to read-only connection, and maybe using something like PGPool, maybe we can connect to our slaves for read-only query and spread the connection, rebalance the load over the server. The configuration is very simple. We still have the restore command. We have a parameter called standby mode. When this is set, the server will never complete the recovery. And archive cleanup command. You say, why we need a cleanup command? There's a massive reason. On our point-in-time recovery, we archive all the archives and we restore the data if we need it. But in our case, when the server starts generating its own kind of checkpoints, we can discard these archives and dedicate to the archive location just a small amount of space instead of storing on a large amount of space. So this command, this program, PG Archive Cleanup, I removed all the crazy parts into the Debian installation. Is very useful because the %r is another WAL file generated automatically by the restart point into the slave. Is exactly the same like the checkpoint. The difference is the restart point is triggered by checkpoints on the master, because also the checkpoints are WAL logged when we set to hot standby the WAL or archive. So when the checkpoint restart point happens, a new value is generated. This is substituted. We tell the archive cleanup where is the archive location, and the archive cleanup does all the rest for us, removes all the not needed files inside the archive. I implemented a slightly more complex system for having multiple slaves, but I'm not talking about this. It's a very complicated script for doing, but I'm still calling the PG archive cleanup over SSH session. So I'm cleaning remotely from the master, calculating the positions of the master of the slaves, querying the control files. If we want the hot standby, so access our slaves, we need to adjust the slave postgres.com. So set the hot standby on, otherwise the database will never accept the connection. And this parameter, take carefully this parameter because it's quite misunderstood. Max standby archive delay. What could it mean? Maximum delay between the master and the slave? Not really. It's not this thing. It's the time between the master of the slave when the queries on the slave are cancelled because of the conflict over the master. So you can have literally one query on the slave with this parameter can last at most 30 seconds. Then it's cancelled, because there are tuples that are changed on the master that should be visible inside the slave. It's a self-protection for the slave to avoid any risk of overloading of tuples replayed over also the commit statuses are recycled more efficiently. Obviously, it means you have to tune down this parameter accordingly with the maximum length of your read-only queries. So we are still talking about the while shipping. So what's the problem? Some limitation for the while shipping. It's not real time. You have to wait for the next while to be switched and delivered before the change is available onto the slave. It means 16 megabytes, rsync or copy or whatever, another 16 megabytes, another 16. So it happens in bursts calculated over the size of the world. Network can be an issue because if you are delivering these files, for example, you have rsync or SCP, establish connection, handshake, deliver the connection, close, again, connect, handshake, delivery, close. So why not stream things? Oh, that's very important. If for some reasons your archive, even just one block corrupted, you lose the standby because the recovery cannot continue. So one bad file delivered to the slave, you are done. You cannot. You have to resync completely the slave. Yes, this is from my point of view, is not optimal because the WAL files are stored in the slave archive and then has to be copied into the master. So you are wasting more time for getting your data replayed inside the shared buffer. So let's go for the last section of our presentation. So now something completely different. Say hello to our pedestrian seagull. It was funny. It was near the Brighton Pier. I got this. This guy was looking at me. Oh. From the 9.4, it was a fantastic release. Now, this supported. If you are using, please consider the upgrade. Next one, next on the list is 9.1. Probably it should happen. Probably should happen now. I think it's already time. The 9.1 is about a bit to die. So introduced the streaming replication, which is what is a streaming replication? Is one network connection, one database connection connects to the database and asks for the physical files, and the physical files are streamed across the database connection. Wow, brilliant! How can we do it? How can we take advantage of this thing? Still, again, some little adjustments. Nothing to on the archive and WAL level side, but yes. Oh, I'm sorry. I'm listing the advantages of this thing. Not everything good, but yeah. The WAL files are streamed using the database connection, and the stream is almost real time because as soon as the WAL is generated, is streamed across the network, block by block. So there's no more need to wait for the switch. The data is sent across the network like a stream. The name is a stream of data. Oh, that's fantastic. The data, the WAL files, are saved inside the PGX log, and they become immediately available for the restore. But it's even better because the WAL file is allocated, and then it's filled up by the streaming replication, and the startup process reads. Meanwhile, the blocks arrives into the PGX log. So the WAL file, it has not to be completely full before starting the recovery, but usually it's immediate. It's very, very fast. Oh, that's killer. Synchronous slaves. You can tell your slave to wait. You can tell your master to wait for your slave to send back the commit status of the transaction replayed, so it will stay in sync. This can slow down massively the master, because the master will wait. Yes, I know. No. I know. But it is an option. If we can afford the slowness, we can have perfectly synchronous slaves. Oh, that's brilliant. 9.4 introduces the replication slot. Because what's the problem? Because I'm streaming directly from the PGX log of the master, if the master recycles the WAL files and the slave is still asking for another WAL file, gone. The replication is gone. That's a big problem. So at the moment, it's quite safe to implement a WAL shifting as fallback procedure for just in case the lag increases too much. Replication slot. You can tell the master to allocate the replication slot and tell the slave to attach this replication slot. And once the replication slot is attached, the master will never recycle the WAL files when the slave requires. What's the problem? Syncing the slave, there's no mechanism to tell the master do not recycle. So for the time of the initial sync, it's still required or an archive or make the archive fail. So in this way, the WAL file will never be recycled. So this is the next step. I'm working on this part. I need to remove completely the archival, and probably I will make the archive command fail. But yes, it's a good thing. The 9.5, probably Christmas, solved this problem. So let's set the master up. For allowing the connection, we need to tell the database that is expecting, the master database is expecting a connection on a virtual database called replication. And also we need to set up the user replication with the privileged replication. Obviously, if you are using Postgres, everything is okay. It's a user, you can do everything. So no problem. You also need to change the max WAL senders, is the number of maximum backend processes dedicated to the WAL sender. Each connection consumes one database connection, so you have to subtract from the max connections allowed. WAL level of standby, because we need to stream everything. This can help us for the problem I mentioned before, WAL files being recycled. WAL keep segment. You tell the database that at least 32 segments has to stay inside the PGX log. Increasing this, please change the size of the PGX log accordingly, or your database will crash, because you have the PGX log on the different file system, right? Oh yes, this is what I mentioned before. PGHBA. How many ate PGHBA? 1, 2, me. Yes. More than PGHBA, I would really like to have the PGHBA editable through a Postgres connection. At the moment, it's my last problem. It's the final problem, and then I can work Same way I used to work with Oracle. Not accessing the file system. Fantastic thing. Anyway, PGHPA, host, user, replication, host connection, user database of the connection is the virtual database replication. The user is the one I created before, the network, and the authentication, MD5. I like it. I think fast sometimes. Not nice. And inside our recovery.conf, alongside with the restore command, standby, all this thing, we have the primary connection info. This is badly written because I set the password inside. It is quite secure if you have your recovery.conf inside the Postgres database area. If you have recovery.conf inside the ETC like Debian does, not exactly nice. So maybe it's better to use the PGPass. What it does, fake database, user, host, password, and port. Simple, plain network Postgres connection. It happens. Start the slave starts the recovery, replay the WAL files from the archive. When there's no more archives to replay, pulls back into the primary connection info, connects to the master, the connection succeeds, if everything is fine, it starts streaming the blocks of the missing WAL files in real time from the master. From PGX log to PGX log. It's quite interesting because at this level, the archive is used only for storing the WAL files for full back procedure, because if for some reasons the stream interrupts, we still have the possibility to continue the replay. Meanwhile, the database catch up with the master. And then 6 minutes. Oh, that's quite fast. That's nice. I prepared a little example on my box, and that's the reason why it's 9.4. Alter system is a fantastic command. You can change the database settings directly from the SQL command. They are saved into a postgres.outlook.conf, which is read before it is more important than postgres.conf. So archive mode on, hot standby, archive command, while senders to. It's just plain Unreal on my PC. While keep segment 32, hot standby, listen addresses. Do not forget that you have to connect from another place, otherwise you will get bye-bye. And yes, create role USL replication with replication login. And this is my configuration in my master. Check the WAL archive is working. This is not obvious, but let's do it. The PGH switch X log, it forces the log switch. So when you set up your box for the archival, just run it by just a double checking and check the archive. Timeline 1, WAL file 1, created from scratch, just for this example, 26th of November, a couple of days yesterday. And so yes, as soon as the X log is switched, it's saved into the archive, and the next log becomes the number 2 available in my database. So on the master, I do start backup, jump to the number 3. This is a short version of the data of the WAL file name, and yes, that's fine. Async exclude postmaster PID from pgdata94 master, from pgdata94 play. Why I excluded the postmaster PID? Because it's on the same box. If I try to start the slave on the same box, the PID of the master is present in the proc file system, and the database will tell you are nuts. It doesn't start. So Yes, stop backup, and here we go. Oh, that's another little thing. Because it's still the same box, I had to change the port into the slave from 5432 5433. Set up the recovery.conf, same thing. Standby mode on, restore command, archive cleanup, and primary connection info. And that's it. PGL start, PGCTL start, Dr. Attabis, database system shut down in recovery, entering standby mode, restore number 7, redo starts, consistent recovery at number 7, because basically I did nothing on my instance. Database is ready to accept read-only connection. From this moment, I can connect, even if it's not yet in streaming replication, I can already connect to the database. Oh, it's missing one file. No such file directed. This is normal. Usually people get scared about these strange errors. It's the way database detects the missing WAL file or an incomplete WAL file. So start WAL from primary, timeline number 1. Fantastic thing implemented in the 9.3, no, 9.2. The streaming replication can follow the timeline change into the master. So if we, because this thing, the streaming replication can also be configured in cascading. So you can connect not just on the master, you can connect on a slave, you can connect on the slave, another slave. If one of the slaves inside the chain changes, all the slaves can follow the change of timeline, and you do not need to resync all the slaves, which is incredibly useful. And connect to the slave, check if this function PG is in recovery. If returns true, it means you are connected to a recovery slave, and you can just run read-only queries. Troubleshoot. The question WAL segment already being removed. Do you have your archive full back? No? Bad for you. So please implement the archive as fallback procedure for your slave. Archive PGX log filling up on the slave. This is incredibly insidious. Usually it's when the slave does not issue the restart point. It can be anything. It can be corruption, or I had one problem when one index was corrupted silently on the master. It was sending wrong records on the slave, and the slave wasn't generating restart points. So sometimes it can be the slave corruption on the control file, and unfortunately in this case requires the complete rebuild. Sometimes it can be the master. Wrong data on the master, pushing rubbish inside the PGX log. Ooh, I know. 45 minutes, that's fine, good. And oh, that's nice. Slave crashes because of invalid pages. This was a very old bug in 9.2.4. The correction of invalid pages on the master was not well logged, and when the slave tried to replay those pages, there was no such page on the slave, and so crashed. Solution: resync the slave, or try to catch the affected relation and resync just this one. If you have several terabytes of data, maybe this is a very useful solution. ILAB between master and slave. This can be vacuum on highly updated tables. It's not a bug, it's the way Postgres recovers. Sometimes for one single tuple, this index rescanning, the replay, can look for several times until all the tuples are put in place and then sync it. So ILAB between master and slave is quite complicated. Usually it's out of vacuum. One partial solution is try to use the out of vacuum, the cost-based out of vacuum. So let the out of vacuum sleep for a while. In this way, the changes will be better digested by the slave. And it doesn't matter the size of the database. It just updates and vacuum altogether without limitation can lead to decent amount of lag between the master and the slave. Questions? Andy?
So, I don't know if I'm just misunderstanding this, but you mentioned earlier about the lag, like 30 seconds, or the timeout in the secondary.
Mm-hmm.
The thing is, if that's transactional-based replication, the slave is replaying those transactions. If that timeout is reached, does that mean slaves can end up in inconsistent states?
The query is cancelled to avoid inconsistent state.
So what happens at that point? He's saying the backup then stops.
If you take the logical backup from the slave.
So you need to just restart the block?
No. It is managed automatically. It's just a query that can lock the change that throws from the master to the slave. This is just cancelled.
Right.
It just prevents the PGC log to fill up and the X log to explode.
How often do you get errors that will cause this to start replaying the logs? You know, in statistics, is it something that happens really often, or
error for sorry?
You know, we get an error,
Mm-hmm.
and you go back and start replaying the logs.
Oh, the CP cannot find the log.
Yeah.
It depends how often the logs are.
Is it something that happens all the time, or is it
if you are connected,
blue?
no, if you are connected to the streaming application, this doesn't happen. If you fall back on the, if you are using just the archive, you will see this often. But it's completely normal. It's not an issue. Yeah, we can use PG standby as restore command.
So do you consider the Postgres matter replication mature, but yet still getting there since the 9.2, but it's not mature yet. Getting there.
I think the
we still have to deal with some
yes,
little things like
we still have issues. The replication slots can have improved this.
Yeah.
The 9.5 probably will be the first very complete replication solution, because alongside this we have also the logical decoding to the slots.
the best way to fix any issue is Resync.
Yeah.
You put the server down, you Resync, and that's it.
Let's see that when the 9.5 comes out, we can start trying and testing.
You might have said this already, but can you do stream replication to multiple slaves?
Yes.
So you can have multiple slaves ready to take read-only requests
Yes.
and distribute your workload.
It's all managed by the max log changes. This is the how many backgrounds can stream through your slaves.
You don't see a concurrency issue potentially. You just
Now, it depends which slave is the slowest. It would be hard to sync. If you want to everything synchronized, you have to use the synchronous. That's it. Good. Thank you very much.